quadratic formula, you're finding the solutions, so you're not actually factoring. You're just skipping the factoring, you're going directly to the solutions. But you could always take the solutions and work towards and create factors like you did in one of the assignments. So it's not all bad. And if that's what you know how to do best, then that's a great way to find your intercepts or your solutions. And then that's good to know you guys are good with grouping and GCF, because that's never going to go away, unfortunately. Next quarter, we're going to start with rational expressions, and those are polynomials divided by polynomials, basically. So your ability to really be successful in this unit and know how to factor and know how to simplify is going to help you so much for the next unit. So really, really important. So that's why I wanted to kind of end this unit quarter with kind of an overview of factoring. So looking at what you guys said, looks like most of you are saying that you want to find the greatest common factor. That is exactly correct. That would be step 1. So what I'm going to do is I'm going to come over here onto the next slide real quick, and we're just going to list the steps. So always, the very first thing you always want to do when you see a polynomial is look for that GCF. Super important. Before you do anything, factor out the GCF. So good job, you guys. And then Miriam didn't quite get to 2. So Emma said multiply binomials or look, solve for difference in squares. Okay, so Emma, I like the look or solve for the difference in squares. Now you wouldn't multiply the binomials because that's if you were like doing the opposite of factoring, you were distributing back into a big polynomial. But oh, backwards, yes. And that would be kind of your GCF, actually. So when you pull out the GCF, you're doing that backwards. And then David, you stopped after the first step, and then Brianna, divide the whole by the GCF. Good, so you're showing me how to pull it out. Okay, so it looks like you guys are really solid on the first step, but then it looks like it's a little bit convoluted on the second step. You're not exactly sure, but Emma, you're on the right track when you say difference of squares. So what we want to look for is we want to look for special factoring patterns. So that would really be step 2. Okay, and then write this out. Okay, so then what am I talking about? So Emma named one of them, and that was difference of squares. Difference of squares. Okay, good. And there's more special factoring patterns too. So we could almost say, and I don't know how many of you gotten to difference of cubes, but that's a special factoring pattern too. So in order to recognize those, and it's actually difference or sum of cubes, I should really say that, because you can factor it if it's a plus or a minus as long as it's a cube. But then that's what we do next, is we start looking for those special factoring patterns that we can find. And included in those, we can actually say grouping if we want to. Okay, because that would be a special factoring pattern. And typically that's just called quadratic grouping, but sometimes you can just end up with 4 terms and you can use grouping. Okay, so always look for the GCF, always pull that out. Then look at what you have left and see, hey, do I have a difference of squares? Do I have a sum or difference of cubes? Can I group? Those are going to be our special factoring patterns for you guys. And then once we do that, we look again. So after factoring difference of squares, difference of cubes, what you're really going to do is repeat step 2. And actually, I'm going to go ahead and say step 1 and 2, because sometimes you might have a GCF in there for some reason if you didn't pull the full GCF out the first time, and then you would want to repeat that. But again, after you factor, don't just stop, because a lot of people stop. Look to see if you can factor those again. So you're not done until you have factored everything completely. In one of your assignments it says factor completely and then solve. So some of you guys factored a little bit like you did the GCF, but then you went right to quadratic formula. So you factored but not completely, and then you solved. So you just have to be careful and really know how to factor everything. Okay, so what I want to do for you guys is I just have a couple of examples. that will help you to kind of do your final factoring, which is called the fundamental theorem of algebra. When we factor all the way, then we can find all the different roots. So when we're finding roots, we can find real roots, which are on the x-axis. We can find irrational roots, like the square root of 3, the square root of 5, things that never terminate, like pi. Those are called irrational roots. And then we can also find those complex roots, like we were talking about before. So you want to always make sure that when you look at the polynomial, you look at the highest degree, and then you can answer this question. So how many factors do you guys think that I should have at the end of this factoring? If I factor this completely, how many factors will I have? What do you guys think? Just type it in your notepads what you guys think. Okay, David has guessed. Miriam, is that your answer? Okay. David, don't erase. You're good. You guys like type it and then you erase it all quick. David, put your 4 back. It's good to talk about. Good. Thank you. Thank you. Emma, Brianna, what do you guys think? Okay, Brianna's 2. Emma, what do you think? Feel free to branch out on your own too, you guys. Emma, that was like, okay. 1 or 21. No, just kidding. 2. Okay. All right. So, David, I think what you said 4 is because you're thinking of highest degree minus 1. I'm thinking that's maybe why you said that. And that represents our turning points. So, if one of you girls, tell me why you thought 2. Oh, I bet I know. Unless you guys tell me. Is it because there's a 2 in front? Nobody wants to answer. No. Okay, Brianna at least answered. That's good. So, Brianna, why did you think 2? 2 different roots or polynomials? Okay. That's okay, Emma. I know you have lots of math on the brain these days. Oh, 2 parts of the expression. Okay, so interesting reason why you guys are choosing that. And this is why we're going over this. This is really, really good. So David, you actually are the closest. The number of factors will always match the highest degree. So when I get finished factoring this, I should have 5 factors. So that's one way for you guys to know if you did it right. There should be 5. And they may not all be real, but there has to be 5. So that's what we're going to look at. All right, so I'm really glad you guys answered that question because then I could see what you guys, kind of what you were thinking. Okay, so why don't you guys tell me what would be step 1 here? What would I do if I was going to factor this? What would I do first? Okay, good. Okay, so what is the GCF then? What would you guys say is the GCF? Okay, very good, David. You're exactly right. We're going to go with that. So the GCF is 2x. So what that means is I'm going to pull 2x out of every term. So it's like dividing by 2x. So if I divide this by 2x, I'm left with x to the 4th minus, and 2 goes into 32 16 times. X goes into x once, so there's no more x. So good. That's step 1. All right, you guys. Now based on our steps, what would I do second? What would be my second step here? What would you guys say? Step number 2. Think about your steps. Unique is coming in. Okay, good, Miriam. Excellent, Emma. Very good. Hi, Unique. I saw you come in. You can just take a notepad if you like. Okay, good. So you guys, awesome job. So remember step 2 is look for special factoring patterns. So if I look at this x squared minus 16, this 2x is done, right? That term is done. I can't break it down, factor it at all. It's done. But if I look at the x to the fourth minus 16, you guys said look for special factoring patterns, and Emma, you specifically said difference of squares, and I do have a difference of squares. So what I want to do then is I've still got my 2x, right? That can't ever be lost. But a difference of squares factors into a sum and a difference of the square root of both. So I would get x squared minus 4, x squared plus 4. So basically, if I were to multiply x squared minus 4 times x squared plus 4, I would get this x to the fourth minus 16. So I just did a difference of squares. Very nice. Okay, so there we go. Let's actually go down to step 3. So what would I do now? You guys looking at this, am I ready to solve? Is everything factored, or can I factor anything else? Okay, good. So I need to repeat. Unique, did you take a notepad by any chance? Let me just double check in case you took, oh, yes, okay. This one, okay. You can have number 5, this sounds good. Brianna, good, you can get the square root, okay. And David, don't be shy. I know all these females are in here, but don't be shy. Okay, so you guys are good. Oh, good. And then Miriam stated it specifically. So you guys are all right on. We're going to repeat the factoring completely. We're going to get the square root of the expression in the parentheses. And then Miriam said specifically of the x squared minus 4. Good. Here, x squared minus 4 is another difference of squares. X squared plus 4 is not a difference. So that one is done. But I can factor this. So here's kind of what I'm seeing. As you guys are factoring, sometimes things get lost. Keep everything, together. So I've still got the 2x, and then this x squared minus 4 now becomes x minus 2, x plus 2, but the x squared plus 4 does not go away. So I have to keep that. Otherwise, if things go away, I can never get back to my original polynomial. So now, you guys, I have 1, 2, 3, 4, 5 x's. Is that how many I should have? Yes. Yes. Thank you, Miriam. Thank you for answering that. David, yes, I saw the Y. And Brianna, good. I should, because how many factors should I have? I should have 5. So that means I should have 5 x's when it's all said and done. But notice each step, you guys. If I count my x's on the first step, I've got 4 plus 1 is 5, so I'm still good. On the second step, I've got 1 out here, plus 2, that's still 5. So I've kept 5 x's the entire time, so I don't lose any of my factors. Okay, so I've gone through, I've done GCF, I've looked for special factoring patterns, I've repeated that, now I'm good as gold. So I'm ready to solve. So I've totally factored. If I just said to you guys, hey, factor this, you'd be done. If I wanted to solve it, and I just want to do that on this one, just to make sure you guys can see all the different types of solutions we have. So what we do is, remember, we set each term equal to 0, and then we solve for x. Well, on this first one, obviously, x is going to be equal to 0. So that's one of our roots. That matches that x. On this one, you guys know that if you set it equal to 0, you would get positive 2. On this one, you would get negative 2. But look at this last one. Okay, so let's try that. We have x squared plus 4 equals 0. If we subtract 4 from each side, we end up getting x squared equals negative 4. But remember, we haven't solved for x if it says x squared. So we've got to take the square root of both sides. Well, taking the square root of x squared leaves us with just x. But here we have a negative, and like we talked about last time, the negative comes out as I. And anytime we're taking the square root when we're solving for an equation, we always have a plus or minus as our option. So we're going to have plus or minus I, and then the 4 can come out as 2. So this gives us two different roots. We have positive 2i and we have a negative 2i. Plus we have a positive 2, and a 0. So I have 1, 2, 3, 4, 5 roots. Notice that I have 3 real roots, 0 and then the 2's. but then I have two imaginary roots. So if I were to graph this, I wouldn't see these two imaginary roots because they'd be on the imaginary plane. So we would not see that. All right. How did you guys feel about that one? Unique, you spelled your name wrong. Yes, yes. Pretty good. Good, good. Okay, good. Very nice. All right, you guys did a good job with the steps. All right, well, there's just a couple more that I wanted to double check with you guys. And they're kind of different. So let's just go through them because this will really help you, like I said, on your very last assignment. All right, you guys, answer this question now. Now that you guys are geniuses with this, how many factors am I going to have when I'm done? How many factors am I going to have? All right, unique. Good. You guys are so fast. All right, so you guys are saying 4, and you are exactly right because we are being raised to the 4th power, so we will have 4. So awesome job. So I should keep track. I should always have 4 x terms. Okay, now this is kind of a weird one, right? So if we go through our steps, do we have, oh, sorry, Emma, maybe bad connection, snowing or something. That's fine, Emma. I know, you gotta go. I know, bummer. Hopefully it's not cutting out for the rest of you guys. Hopefully you guys are all good. Okay, does anyone know, because obviously if we look at this, first of all, is there a GCF that we can take out? No, exactly right. Very good, you guys. No, there's not. So then I have to look for special factoring patterns. So, I kind of run through these in my head. Is this a difference of squares or a sum or difference of cubes? Unique, is that a O? Does that mean no? No. It's not any of those. So does anyone know how I could start off factoring this? Does anyone have any idea? Unique, I think I was reading what you were thinking. Are you trying to say quadratic? Okay, so quadratic formula, but that wouldn't be to factor, but you could use that to solve. But you couldn't use that to factor quite yet. And then we've also got the problem with the quadratic formula is that this isn't really a quadratic just because we have x to the 4th instead of x squared. So we'd have to do some manipulating, and that might be a little confusing. So, but we were kind of talking earlier, Unique, that quadratic formula, you can definitely skip all the factoring steps and you can go right to quadratic formula to find a solution, but it won't help you to factor. So are you thinking of something else? It does have the word quadratic in it, if anyone can think about that. Unique's giving it another try. Yes, yay, quadratic factoring, exactly, exactly. So if you're thinking quadratic formula because it looks like a quadratic, you're close because you can use quadratic factoring to actually factor this as long as you have, 4, 2, and a constant term, you can actually use the quadratic factoring. So we would have negative 45 on top. We've got a 1 here. 1 times negative 45 is negative 45. And then a 4 here. So a 9 times 9, 18 times 5, yeah. 9 times negative 5 is negative 45, and 9 minus 5 is 4. So we can break this apart. Just be careful when you guys are breaking this middle term up. This is an x squared term. So we would have 9x squared minus 5x squared minus 45. Okay, so now we can just do our grouping. In our first group, we go to our GCF. So that's why you guys have to be good with the GCFs, x squared plus 9. In our second group, we can pull out a negative 5 and also get x squared plus 9. And I know you guys said you felt pretty good with these, so I'm just going to kind of go quickly. We end up with x squared minus 5 and x squared plus 9. So let me ask you guys, am I done factoring then? Do I have everything factored down to the smallest? What do you guys think? Unique is yes, Brianna's no. David, I think you're a yes. Miriam is a no. Okay, so you guys that said no, though what else could I factor? What else could I factor? Ah, okay, so I'm glad you said that, Brianna. So that would be our next step, but that is actually how we solve by taking the square root. So as far as the factoring goes, I can't break those down anymore, but my next step would be then to solve. So really what you mean is, yes, we're done factoring, but we could actually solve. Okay. All right, you guys. So we are done factoring. What I want to do now is do the same thing I did before and set each term equal to 0. So if I do that, remember that when I take the square root, I'm going to get plus or minus the square root of 5. So this is an irrational number, and if I put it into Desmos calculator online, let's say, I would get, 2 point blah, 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 blah. That's not a number that I can work with, so I always just leave it as plus or minus the square root of 5. That's easier to work with. And then on this one, we have x squared plus 9 equals 0. So x squared equals negative 9. When I take the square root, I'm going to get plus or minus 3i. Okay, so I have 2 x's here. I have 2 x's here for a total of 4 roots. I can check my factoring right here. I have 2 x's here, 2 x's here, so I have 4 factors, and that's how many I needed, 4. So I'm in good shape. All right, you guys, so sometimes you have to solve these manually, and you can't always graph, because like I said, if I were to graph this to try to find my roots, I would not see these complex roots, and I would not be able to figure out an exact value of square root of 5 on those. And that is what I'm going to show you guys for the last one. Are there any questions on that one? Nope. Nope, nope. Probably erased your name. Okay. All right, good, you guys. Well, here's our last one. So what I did is I graphed it ahead of time so we wouldn't take a lot of time. But I put this whole big old long equation into Desmos, and this is what I got when I graphed it. Notice that we have this negative 2.2, who knows what number that is, right? But then we have this negative 1, that's a real integer. And then we've got this positive 2.2, probably goes on forever, don't know what the exact value is. And then we've got a real 4. So I have 2 real roots here, and then 2 probably complex roots. And then let me ask you guys this. Looking at the graph and looking at the equation, are all my roots, can I see all my roots? What do you guys think? Okay, so, well, Unique, let me ask you this. How many factors, let's go back to the original question. How many factors should I have looking at this equation? Okay, good. 4. Okay, so good, Brianna, 2, also 4. So Unique, if I have 4, because you guys are saying 4, yep, see David agrees. If I should have 4, can I see 4 roots? Because the factors and the roots are basically the same, right? Your roots are just your factors solved. Yes, good. So that's how I know that I'm seeing all of them. So I know I don't have any imaginary ones. If this was 3x to the 6th, then yeah, I would have imaginary. And you guys can kind of start to see a pattern that in order to get an imaginary root, you have to take the square root of a negative number. So you're always going to have 2 imaginaries. If you won't just have 1. Same thing with these irrational numbers. And to get an irrational number, you have to take the square root of something. So you always have a plus or minus. Okay, so yeah, I can see them all. Now you guys, here's one method of factoring, and I put it up on that poll. It's the synthetic division. That's one way to factor. That's kind of helps you to break down the polynomial into a smaller thing, I guess I would say. So let's think about these roots here, these -1 and 4, because I can use those right now. If I go over to my equation, I can use my synthetic division. What did I just say? -1. Look how forgetful I am. Okay, so we can use the -1, and I can factor out that -1, which is basically a factor, an x, from this polynomial. Now the one thing that I see that you guys are doing when you do that is that you're not realizing that you're factoring or dividing out an x. So once I do that, I will no longer have an x to the 4th, I will have an x to the 3rd. So let me show you that. So we've got the 3, I'm writing all the coefficients, right, for our synthetic division. And I'm making sure that I don't need any placeholders, and I don't, because it goes 4, 3, 2, 1 constant term, so I'm good. And then some people set these up a little different, but we'll do it like this. All right, so remember, bring the first term down, multiply diagonally, add down, multiply diagonally, add down, multiply, add down, and multiply. Okay, so good. I should get 0. If I don't get 0, then I know, Unique, I love that method too. Isn't it awesome? It's so fast. But yeah, if I don't get 0, then this 1 was not a root, right? It was not a factor. But I did, so it's good. Okay, so here's what I want you guys to see. So these numbers down here, remember where I got these numbers? These are just coefficients. So these are coefficients too. But now, instead of x to the 4th, I'm going to have x to the 3rd, and then x squared, and then just x, and 60. So, you know, set that equal to y or 0, whatever, depending on what I want to do. So what I've done is I have factored out x plus 1, basically, right? That's the factor for a root of -1. So I've taken and I've factored that out, and I made my polynomial a lot smaller. What I could do now is I could actually group, right? Because I could take this first 2 and I could take the second 2, and grouping works on this. So I could totally do that, and you guys know how to do that. Or, and I say or, remember that when I graphed it, I had another rational root of 4. Here's a cool trick, right? So I could take that 4, and I could factor it out of my new polynomial, this bottom one. So I can go 3, -12, -15, and 60 to get my polynomial down to a quadratic if I would rather have a quadratic. So when I do that, -60, I get 0. So again, I just did the synthetic division again real quick. And now, instead of x to the 3rd, I have x squared, and then this is plus 0x, but it's still, you know, an x. And then the -15 on the end. Okay, so things are a little crazy right now. I've got stuff going all over the place, but I need to keep track because I got to have 4 factors for roots. So what I'm going to do over here is see where I am. So I've got this 1. This is the x plus 1, right? I've got this 4. This would end up being x minus 4 if I wrote it as a factor. And then I've got this down here, 3x squared minus 15. So let me ask you guys this question, one of your final questions of the night, of the afternoon really. Am I done factoring 3x squared minus 15? What do you guys think? Am I done? Okay, so remember all the rules. So we're getting a couple yeses and no. Miriam's holding out. Miriam's a no. Brianna was a yes, but then she deleted. David's a yes. So many different questions here, or answers, I should say. Yeses, nos. All right, you guys, let's think back to our steps. Step 1 is GCF. So, David, let me ask you this. Do I have a GCF in these terms? Is there anything that goes into the first term that can also go into the second term? No. No. Brianna, yes. All right, David, check this out. Can 3 go into 3 and also into 15? Ah, yes, yes, very good, very good. Excellent. So that's why we always have to think about our steps. So every time we think we're done, we just need to rewind, go back to the beginning, see if we really are done. So good, you guys, good. So those of you guys that said no, I'm assuming you guys were thinking this too. So we need to pull out a 3, and then we get x squared minus 5. Okay, so I'm going to add that here. X squared minus 5, and then it doesn't matter where I put my 3, I'll just put it in the front. All right, let me count my x's, make sure I have 4. So I've got 1, 2, 3, 4. I've got 4, that's awesome. If I set each of these equal to 0, well, I already know what this one is, right? This one is equal to -1. I pulled it right off the graph. This one is equal to 4. And then these are the two that I didn't know what they were, right? Because they were some kind of irrational number. So if I set x squared minus 5 equal to 0 and solve, and I take the square root of both sides, I get plus or minus the square root of 5. So that's what those numbers were. They were square roots of 5. And I don't need to worry about the 3 because there's no x with it. So it's just a factor, a multiple, I guess is what I would say better, because it doesn't have an x on it. All right, you guys, so I have my 4 solutions and I have my 4 x factors, so I am in good shape. All right, any questions on the factoring and going through the steps and the synthetic division? Kind of covered a lot, actually. Okay, good, Unique, good. Very good. Awesome. I'm glad. Good job, you guys. Okay. Well then, so for your ticket out, and we pretty much answered this, will be really easy for you guys. All I want you to do is list the steps to consider when factoring, right? There's only a few. Include a little bit of detail for each step, like, what does that mean? And then, how do you know you have factored completely and correctly? Think about that one. That's kind of like, everybody's going to answer that a little bit differently maybe, but think about that. And that's in your discussion already in Schoology, so if you go in there, that question will be there. All right, you guys, so awesome job. One last thing before we go. This is the last week, right? And so really make it count. And some of you guys are just doing a phenomenal job this quarter. I'm so proud of you. And then there's a couple of you guys that started off great and then kind of slowed down. So you have time. You can do it. You've got today, tomorrow, Thursday. So, make it count. Get some work done as much as you can. And then check, in Infinite Campus, check your grade. But remember, your grade is kind of based on how much work you've done so far. So if you don't make any progress, there is a chance that your grade could go down. And I messaged a lot of you guys about, different things. So if I didn't message you, it's probably because you're like, hey, right on track. But are there any questions that you guys have of me for grades last week, concerns? I'll be at Gateway tomorrow.